All right, good morning, scholars. How's it going today? This is Mr. McCaffrey, and we're going to be starting now section 3.2, logarithmic functions and their graphs. This is why I'm doing a screencast today. It's because I have a big zit on my nose, and I don't want you guys to start laughing at me. So no laughing. Actually, you guys can't even see me anyway, so haha. Here we go. All right, so we're going to be talking about logarithms, and I know this is not a brand new concept to you, but I'm going to start from basically what the definition is, and then we're going to start on some problems here so that we can just briefly review what it is here. So, okay, so what is a log, right? So before we do example one, let's just first go to a blank page here, and let's talk about what a logarithm is. And there's the bill. Okay, so say if we define, actually let me get my little pen out, and there we go. So say if we say y equals, but we don't want to do that though in yellow because that's not going to work out very nicely. So let's actually try something that you can actually see. Try this. So if we have y equals the logarithm, okay, and we're going to talk about what that means here, sub a of x. So check this out. The way that we read this is we say log base a of x. So we call this right here our base right here, okay? Every logarithm has a base. Every logarithm, okay? Even if they don't even put a number right here, a subscript, there's still a number there, and which is going to be 10. We'll talk more about that, but there's always a number here. If they put a 4, then that means that's the log base 4. If it's a 7 here, but then if there is no number here, it's always a base 10. So the way that we say this is log base a of x. Log base a of x. So what the heck does this mean anyways? Well, look here. This whole thing is the exact same thing as saying this, okay? Now, let me show you the equivalence. This means we take our base a. That means a, right here, raised to the power of y. To the power of y equals x. That's what that means. So these two statements are equivalents. Okay, they go back and forth. So when I say a to the power of y equals x, what's the same thing as saying y equals log base a of x. Okay, so write down that definition. This is what the definition is. And we're going to use this definition now to do these problems. So let's go through these guys and hopefully make some sense here. And we don't want you as well. Okay, so we have example number one, part A. So we have our function f of x equals log base 2 of x. Now let's remember that this right here is the same thing as saying y, okay? F of x is just a fancy way of saying y. You need to get used to saying f of x though, especially now when you're in trig pre-calc and when you go into calculus next year. You'll hardly ever see y equals something. Now it's always going to be f of x. So just kind of get used to that. That's what that means. So they want to know what is f of x equals log base 2 of x when x equals 32. So let's just replace that, okay? Is that okay right there? Let's just go ahead and replace that. So say if we replace x, let's replace x with 32, okay? Equals log base 2 of 32, okay? So now what does this mean, right? I mean, isn't that what we're trying to figure out right now? We're trying to figure out what does log base 2 of 32 mean? Well, let's think about this, okay? Let's convert this into what we call exponential form, what we just did like in the definition. So watch this. This means we take our base, right? 2 to the power of this right here, but we don't know what this is. So we're going to say 2 to the power of what equals 32. That's exactly what this means. This means 2 to the power of what is 32. So when we're trying to find our answer right here, we're really looking for x. And hopefully we all know now that 2 to the power of, let's see, 2 times 2 is 4, times 2 is 8, times 2 is 16. So it would be 5 then, right? Because 2 to the power of 5 equals 32. So the answer that we're looking for right here is going to be 5. So this would be our answer, 5. All right, let's try a few more here. We have 4 parts to this. Let's go and try B, C, and D. So moving on right here. Let me try black here. Okay, so let's do the same thing. Let's find the log base 3 of x where x is 1. So basically we're replacing x with 1. So f of 1 equals, well, that's a really fat marker. Change that there. Let's see, I don't know if I do that. Equals, there we go. It's probably a little better there. Log base 3 of 1. Okay? So, if you're like, what the heck is log base 3 of 1? What is that? Well, what they're looking for is some number right here, right? And so this is how we find that number. We convert this into something that makes sense to us, which is 3 to the power of what equals 1. That's what this means. 3 to the power of what equals 1? What's anything? I'm sorry, anything to the power of 0 is 1, right? So this is why we can say x equals 0, because 3 to the power of 0 is 1. So our answer then would be 0 then for part B. Okay. Moving on right now. Going on to part C. So it's going to replace x with 2 here. So f of 2 equals the log base 4 of x. Wait, but we're going to replace our x with 2, right? So let's just replace that right there. So 2. So log base 4 of 2. Well, that again means 4 to the power of what equals 2. Now, if you think about this now, okay, we know 4 to the power of 0 is 1. 4 to the power of 1 is 4. 4 to the power of 2 is 16. So we're like, oh, no. I guess we can't. What do we say? It's undefined? No. Look, we can still do this. And watch this, though, okay? See how this is a 2 right here? Can't we rewrite 4 as 2 to the power of 2, right? 4 is the same thing as 2 to the power of 2, right? Now, let's replace the x up here. Okay, feel me right now. Okay, watch this. Do you see how these two have the same base? Right? They have the same base. So we can set their exponents equal to each other. And we know that this right here is a 1. So look, we say 2x equals 1. So x must be a half. Oh, let me talk about that real quick. What does that mean? Look. 4, look, to the power of 1 over 2 is the same thing as the square root of 4. Because look, our bottom number right here, I know I'm giving you a lot of little small rules, but you should have learned these in Algebra 1. This bottom right here is always your roots. So we took the square roots, and the square roots of 4 is 2. So fractional exponents are just roots. Oh, well, okay, watch this. Let me give you one more right here in this little corner. Look at it. Let's do 27 to the 1 over 3. You're like, what the heck is that? Again, this 3 means that right there is a root. So the third roots of 27. Well, that right there is what times what times what is 27. Well, that's going to be 3. So a little something right there. Last but not least, part D. So we want to know what is log base 10 of x as x equals 1/10. So we're going to replace x with 1/10. Okay, so we go like that. Log base 10 of 1/10. What does that mean? Well, let's convert it, right? When we write this equivalent, we call that exponential form. So this is called logarithm form. I can convert this into exponential form, which means 10 to the power of what equals 1/10. Okay, so this is called the exponential form. This is called the logarithm forms. And so it's always easier to put things in logarithm form because we know how to do stuff like this. All right, so let's see, 10 to the power of what is 1 over 10? Another rule to review from Algebra 1. We know that if this right here is a negative number, it puts it in the denominator. So watch this. If we do 10 to the negative 1, that's going to be the same thing as 1 over 10 to the 1. So basically you take the same thing right here and you put it in the denominator, but now you make it positive. And just to clarify this, say if I said 10 to the negative 2. Oh, well, that means 1 over 10 squared. Or what if I did 10 to the negative 4? Oh, well, that's the same thing saying 1 over 10 to the 4. So the way that we get rid of negative exponents is we put the whole thing in the denominator and put 1 over right there. And that's the conclusion of our first video for example number 1.